Now, as we mentioned earlier, when we have a network, we have a group of interconnected devices. So, how do we connect those devices? We connect them through media and through specific devices designed to connect computers. Hubs are what we used to use very commonly back in the day, simply for the fact that they were cheap. But hubs introduced problems and some security vulnerabilities into the network, so we moved from hubs to switches. Switches give us greater control of traffic, and switches, in a lot of ways, act like a police officer of a busy intersection, directing traffic from one path to another. Switches will allow you to manage traffic on your network more efficiently. Routers are primarily about connecting to different networks. If I want to connect to the internet, I usually do so through a router. If I want to connect to my branch in Minnesota, usually I connect to an external network through my router. VLANs are going to give us benefits of both switches and routers. A VLAN is going to be a virtual LAN, so we'll be able to segment our network into different subnets, if you will, and we can do so on a switch. We'll talk about why that's desirable later. And then, of course, we have to consider wireless access and wireless access points, and how we'll allow these hosts to connect without being physically wired in. Another thing to consider is VPN servers, and with wireless and VPN, we'll talk about those ideas when we get to the remote access section. Every one of these terms we'll go into more deeply. The next thing we have to have if we're going to allow communication is a protocol. A protocol is really important because you could think of this as the language that computers speak, and we have to speak the same language. Quite honestly, that's not the best definition you're going to hear, but it's a good way to think about it because if I'm speaking Greek and you're speaking Spanish, we're not going to be able to communicate unless we have a translator. The more translators we have, the more unreliable the communication is. If you ever want to do something fun, use Google Translate to speak a phrase and translate it into Spanish. Then take that Spanish phrase and translate it back to English. Then take that result and translate it back to Spanish. Do that about 10 times, and you'll find the end result is hysterical. By the end, you don't have anything like you were originally communicating. And that's the problem when it comes to protocols. When you have too many different protocols, even though we can get a conversion and can get a device called a gateway that's a protocol converter, we don't get good, true communication. So, what we like to be doing is to all use the same protocol. A better definition of a protocol is that it's the set of rules and requirements that govern communication. So, things like how much data can be sent at once, how do I know if I'm sending more data than you can receive, how long should data exist on the network, and how should the packets be formatted are all examples of information that make up a protocol. But again, from this standpoint, you can think of it as a language. We have to share the language. The most common protocol we have and use by far is the TCP/IP protocol. It's actually not a protocol. It's called a protocol stack or suite. It's called a protocol stack because it's made up of a lot of little protocols. As a matter of fact, you already know two of these protocols, TCP and IP. There's also HTTP, UDP, ICMP, LMNOP, it feels like. There are a lot of protocols that make up the TCP/IP suite, and each of them have a particular purpose. Just like everything, we're going to go over this in more depth later. The medium, cable or the airwaves. And with cable, there are three main types that we use for networking: coaxial, twisted pair, and fiber optic cable. Each of these are in use today, and they each have their place. We'll cover this in another chapter where we get into more details in the specifics of mediums. We have to have cable or airwaves we're going to traverse because we need that path for data to travel. Ultimately, what we talked about here is the fact that there are a lot of elements that have to come together if we're going to be able to share resources and communicate across the network. At the very basic level, we have the systems we want to connect. Then, if we want a domain environment, we have to have a network operating system, and that creates the domain or the realm. We use connectivity devices and protocols, that way we can agree on how to communicate. And of course, there is media, which is what we traverse. I'll also mention here we have certain network services that we utilize, like DNS and DHCP.